Hello and welcome back again to our channel, Tutoring Made Easy. The goal of this channel is to provide us with all the tutoring help that we need, tutoring help in many subjects. So you're welcome back again, and I hope you're doing well. In today's video, we're going to look at fractions. All we need to know about fractions. We have previous videos on fractions, but it deals with each topic at a time. But here in today's video, we're going to have a very comprehensive video on fractions so that we can be able to know all that we need to know about fractions. So we're going to look at 10 things. 10 things. So the first one we're going to look at is to look at the definition. We're going to look at the definition of fractions. The second thing we're going to look at is the types of fractions. Yes, there are different types of fractions. The third thing we're going to be looking at is how we're going to be able to change, a mixed fraction, into an improper fraction, an improper fraction. We'll get to know that in a little bit. The fourth thing is also to look at how we can also be able to do addition, how to do addition, subtraction, multiplication, how to be able to multiply fractions, and then also how to divide or do the division of fractions. Yes, that'll be the fourth thing. The very fifth thing is to look at how we can be able to see the relationship between fractions and decimals. So fractions and decimals, and how we can be able to change a fraction to a decimal, and also a decimal back to a fraction. The sixth thing there, since we're going to look at decimals and fractions, it will be prudent to look at how we can also look at fractions and percentages. We'll look at fractions and percentages before we look at decimals and decimal places and significant figures. So fractions and percentages, we can also look at that and how we can be able to change that percentages back into fractions as well. Then I think the seventh thing will be decimal places. We're going to look at decimal places and I think significant figures. Decimal places. We're going to look at the eight things to look at significant figures. And then the ninth thing, we are going to look at standard form. We're going to look at the standard form, how we can be able to change any number or a decimal into a standard form. And the 10th thing is to look at BODMAS, and usually BODMAS relates to fractions. How we can be able to use PEMDAS, is it PEMDAS and BODMAS. Yeah. I'm gonna look at that. I think it's. Let me quickly confirm that. I think it's PEMDAS. Yeah, it's PEMDAS. For those my friends in the American, so it's PEMDAS and BODMAS. PEMDAS and BODMAS. So that'll be the 10 things we're going to look at there. So once we're able to digest this particular video, it will give us all the comprehensive things that we actually need. All the comprehensive things that we actually need to be able to know what fractions are all about. Okay, so let's start off with I think the definition. Let's start off with the definition. The definition of a fraction. The definition of a fraction. I think that we mentioned earlier in some previous video that a fraction is a part of a whole. A fraction is a part of a whole. Fractions are usually part of a whole. They are usually part of a whole, and usually they are represented. In this form, represented in the form. They're represented in a certain form, in the form A over B, where B cannot be equal to 0. Because when B is 0, it makes, if B is 0, then it means undefined. Why? Because we're going to have A over 0, right? So a fraction is a part of a whole. And it's represented in the form A over B. And the A there is a numerator. The one on top, which is the one on top, is known as the numerator, and then the B is known as the denominator, the denominator, which is the bottom one. So we have the top and bottom. We have the top and bottom. So the definition of a fraction is that it's a part of the whole. It's a part of the whole, and it's also represented in the form A over B, where B cannot be zero, and A is a numerator, is on top, and then B is the denominator. I think we're going to continue, and then we're going to look at the types. We're going to look at the types of fractions. We're going to look at the types of fractions, and the first type of fraction is what we call the proper. Is known as the proper fraction, and usually the A is smaller. Usually the A Usually the A is smaller. The A is less than the B. A is smaller. So the numerator, we're saying that the numerator is less than the denominator. Less than the denominator. And an example of that is maybe 1 over 2, or we can have 4 over 7, or let's say 9 over 13. So those are examples of a proper fraction. The next one is I think the next type is known as the improper. It's known as the improper fraction. It's known as the improper fraction. It's known as the improper fraction. The improper fraction. Yeah, and in the reverse is the reverse of the proper, the reverse of the proper fraction. So here we have our A. A is greater than B. That means the numerator is greater than the denominator. The top is bigger than the bottom, and when that happens, we are having examples such as, let's say, 3 over 2, or 4 over 3, or 9 over 4, like this, in this form. That gives you, anytime you see something the denominator being small, the numerator being bigger than the denominator, is a type of what? An improper. It's a type of an improper fraction. Now the last type of fraction is what we call the mixed fraction. It's known as the mixed fraction, and with a mixed fraction, you are having a whole number. There's a whole number and a proper number, a proper fraction. So you're gonna have something like this. You're gonna have maybe A is a whole number, and you have B over C as a fraction attached to the whole number. So there's a whole number. This is the whole number, and then this is the fraction. This is a fraction. So example of such a case is when you have, let's say, 5 whole number 1 over 7. For example, is a mixed fraction. So the first thing, I think we've done the first one, and then we've done be able to do the second topic, which is the types of fraction. Now we're going to look at how we can be able to convert a mixed fraction. How do we convert a mixed fraction into what? An improper fraction. So that's what we're going to look at, and how we can be able to change a mixed fraction to an improper fraction. So let's quickly look at how we're able to do that. We have a case like this. Let's say this is our mixed fraction, a whole number, m over n, for example. What we're going to do is that we're going to take the whole number and multiply that by the numerator. We're going to multiply by the numerator, which is m, and then we add the denominator to the whatever we get after multiplying. That we add the denominator, and then once we are done, we divide everything by the denominator. So basically, we are saying that it is the whole number. The whole number we multiply by we multiply by the numerator, and then we add the denominator to it, and then we divide everything by the denominator. So we are saying that that's how we go about it. So let's take maybe an example. I don't know what an example will do. Let's imagine that we have 5 whole number 1 over 7, we are saying that take the whole number, which is 5, multiplied by the denominator, which is multiplied by the denominator, which is 7, and then add it. We add it to the numerator. We add it to the numerator. We add it to the numerator, which is 1, and then we divide everything by the denominator. Divide everything by the denominator. So I think there's a little. Let's do a little trick here. Let's imagine it's a whole number, and then we put on an n and over m here, where we have a multiplying the denominator and adding to the numerator and dividing it by the what? And dividing it by the denominator, like this. So it is the whole number multiplied by the denominator. I think that I have to change this formula. Sorry about that. Sorry about the confusion. Let me quickly do that for us. Sorry about that. We're saying that it's the whole number multiplying the denominator, and then we add the numerator to it. And we divide everything by the denominator. So it's the whole number multiplied by the denominator, adding the numerator to it, and dividing everything by the denominator. So that's what we're doing here. Nothing changes. It's a 5 multiplied by the denominator. We add it to the numerator and divide it by the denominator. So here we're going to get 5 times 7, which is 35. And then we're going to add it. We're going to add that 35 to the 1, and we divide everything by 7. So we end up getting 36. Over 7. Let's take another example. Let's take a quick example. Let's say we have two whole number, 3 over 4. We're saying that take the whole number, multiply by the denominator, add it to the numerator, and then divide everything by the denominator. So we're going to get 8, which is 2 times 4 is 8, plus 3 divided by 4, and we get 11 over 4. So I hope so far this is actually helping, and you can be able to see. Sorry about the hitch that we had earlier. Now let's also look at how we are able to convert an improper fraction. How do we do that? How are we able to convert an improper fraction? We're converting an improper fraction to a mixed fraction. How do we do that? An improper fraction to a mixed fraction. So let's imagine that we have, let's say 9. Let's say we have 9 over 4, which is an improper fraction. How do we change it to a mixed fraction? There are two methods I'm going to mention. First method, I don't know whether it's going to be easy for you, but first method 1, I'm thinking method 1, you just ask yourself the denominator. How many times does the denominator, which is 4, go into 9? We know that 4 can only go into 9 2 times. So 4 goes into 9 2 times. Why is it 2 times? Because we know that 2 times the 4 is 8, which is closer to the 9. So 4 goes in 2 times, and there'll be a remainder. Of 1. Why? Because it's just 9 minus the 8, which is equal to 1. So that's the remainder that we are getting. And as we get that remainder, we have the whole number, which is the 2 times, and then the remainder is the numerator, and then we divide by the denominator, which is 4. So we can check 2 times the 4, adding it to the 1, dividing everything by the denominator, we get 8 plus 1 divided by 4, which is 9 divided by 4. I hope this helps. Let's take maybe another example. For let's say for the same method 1. Let's say that we have let's say 10 over 3. We are saying that 3 goes into what? 3 goes into 10. How many times? It's 3 times. So that's 3 whole number, and there'll be a remainder because 3 times 3 is 9. So there'll be a remainder of 1 to give us a 10. So remainder 1 divided by the denominator, and then there you have it. Now the next thing we're going to do, we've been able to look at the definition of fractions. We also looked at the types of fractions. A fraction is a part of a whole. We also said that it's represented of the form A over B, where A is the numerator and the B is the denominator. We also said that the types of fractions are proper fraction, improper fraction, and mixed fraction. Proper fraction, we have the numerator smaller than the denominator. In the improper fraction, we have the numerator bigger than the denominator. With the mixed fraction, you have the whole number and a fraction attached, to it. And we've been able to look at how we can convert a mixed fraction to an improper fraction. We said we'll take the whole number, multiply by the denominator, add to the numerator, and divide by the denominator. We also looked at how to be able to convert an improper fraction to mixed fraction. We will look at the method 1. So we are going to look at method 2. We're going to look at method 2 on how we're going to be able to change an improper to what a mixed. That's what we're looking. We're looking at method 2. And remember, we started with, let's say, 9. I think we started with 9 divided by 4. So here, what we do is that we make the 4. The 4 will come out, and then you have your 9 to go inside the long division. We say that 4 goes into 4 will go into this 9 2 times, so that the 2 times the 4 will give us 8, and then we subtract. We get 1 here. So this is the whole number, which is 2, and then this is the remainder. This becomes the remainder, which becomes the numerator, which is the numerator. The numerator is the remainder, and then this one here is the one. Is the denominator. We normally call this the divisor. That's the divisor, and we call this one the quotient. The quotient. We call this one the quotient, and we call this one the dividend. The dividend. We will talk about that when we get to maybe equations and polynomials. We'll get it later. But I hope this one works. So whichever one works for you, use it. Let's say we have, let's say we also have maybe another example, maybe the one with the 10 over 3. We said I let the 3 come out, and then have your long division, and your 10 is inside. 3 goes into the 10 3 times, so that 3 times 3 becomes 9, and we subtract, we get 1. So this is the quotient, which is the whole number. This is the whole number. This remainder is the numerator, and this is the divisor becomes the denominator. So if that's the case, we say that this is the quotient is our whole number. So we are going to have 3 whole number, and then we said this is the remainder, right? We said the 1 is the remainder, which is the numerator, right? So that'll be here 1, and then this is our divisor, which is the denominator. So the denominator will come in over 1 over 3, and there we have it. So we looked at method 1, and we've also looked at method 2 for how to convert an improper fraction to a mixed fraction. Now we're going to continue this fraction. So if you are joining us, please do not forget to subscribe. If you're already a subscriber, we want to say a big thank you for supporting our channel. We're going to look at fractions and how we're going to be able to add fractions. So we're going to look at how we're going to be able to add fractions. So we're going to look at addition. First, we look at addition of fractions, and later we'll look at maybe subtraction. Addition of fractions. We look at subtraction, we look at multiplication, and then the division. So we're looking at addition of fractions. And to do that, we're going to imagine that we have 2 fractions. Maybe we have A over B, and we're adding it to C over D. What we do is that we write again A over B plus a C, write again plus a C over D, plus a C over D, and what is going to happen is that we cross multiply. We let this A and D multiply together, so it's going to be A times D, and then we'll bring the plus sign there, and then we'll let this B and C also multiply. So B times C will multiply, and then we divide everything by the multiplication of B and D. We have B times D, and we have A times D is called AD, plus the B times C becomes BC, divided by B times D, which becomes BD. So we can look at an example. So let's take an example for the purposes of our discussion. Let's say we have 3 over 4, and then we are adding it to, let's say, 1 over 7. We are saying that what we're going to do is to rewrite this again, 3 over 4 plus 1 over 7, and then we are going to what? We are going to cross multiply. I'm going to cross multiply. We'll let this one multiply this. So we're going to get 3 times 7. And then we'll bring our addition sign and we let 4 multiply 1. So we're going to get 4 times 1. And then we divide everything by the multiplication of 4 times 7. And then basically we are going to have 3 times 7, which is 21, plus the 4 times 1, 4 times the 1, which is 4, divided by the 4 times the 7, which is 28. So we end up getting 25 over 28. I hope this helps. I hope this helps. Then let's move on. Let's move on to subtraction. Let's look at subtraction of fractions. Subtraction of fractions. So let's look at maybe the same example. Let's say we have let's say 4 over 5, and we have this is minus maybe 1 over 8. Let's say 1 over 8, for example. We're saying that the first thing we're going to do is to rewrite this again. We have 4 over 5 minus 1 over 8, and we're saying that we're going to cross multiply whatever we did for whatever we did for addition, the same rule is going to apply here. The only thing is to indicate the negative or the minus sign, the minus operator or the mathematical operator, right? That we need to indicate. That's going to be the difference between addition and the subtraction. So let's imagine that we are multiplying these two together. We are going to get 4 times 8, and then we bring the sign minus. This negative sign will come here. It will be here. And then we're also going to multiply this one by this. We're going to multiply 5 by 1. We're going to get 5 times 1. And then we divide everything by 5 times 8. We multiply the 5 and 8 together. And remember, 4 times 8 is 32, minus 5 times 1, which is 5, divided by 8. 5 times 8, which is 40. And then we are ending up going to get 27 over 40. 27 over 40. I hope that one helps. Now let's move on. We're going to move on to multiplication. We're going to look at multiplication of fractions. We're going to look at multiplication of fractions. And to do that, let's imagine again that we have, let's say, A over B, and we're multiplying by C over D. All right. The first thing is we look out for common factors. So if we pick A, for example, if we pick A, we should be looking at how does the A, is there common factors between A and B? Okay, so let's say we're looking for common factors, right? So we're looking for, if we pick A, look for common factors for B, for A and B, or for A and C, for A and D. So it's A here and B, or A here and D. That's it. But if we pick, let's imagine that if we pick B, we look for factors. We look for factors that are common, for what? A and B, or let me put it this way, for B and A, common factors for B, because we picked B. So for B and A, and also for what? For B and C. So you ignore the number that is on the same level, on the same line. If you pick A, then you have to ignore the C. If you pick B, you have to ignore this D, like that. So basically, if we are looking at A over B times C over D, we pick one of the letters, and then we look out for common factors for the numbers that are not on the same line as the number that we have picked. So let's say that for a second we have an example. Let's say the example we have is 3 over 4, and it's being multiplied by, let's say, 12 over, let's say, 13. For example, we have this. What we're going to do, we're looking for common factors. So if we pick 3, we are going to ignore this. If we pick 3, we ignore this. And then we look for, is there a common factor between 3 and 4? No, there's no common factor between 3 and 4. Is there any common factor between 3 and 13? No. Now we also try to pick 4. Once we pick 4, we ignore this. Once we pick 4, we ignore the 13. And when we do that, we ask ourselves, what's a common factor between 4 and 3? And there's none. But what's a common factor between 4 and 12, and I think that's 3. So 4 will go here. We have 3 over 4 times 12 over 13. 4 goes here, 1, and goes into the common factor between 4 and 12 is 3. So we end up getting 3 over 1 multiplied by 3 over 13. And here, there's nothing more we can do. There's no more common factors. So what we do is, since there's no more common factors, what we do is to multiply the numerators, which is 3 times 3. We multiply them together and divide it by 1 times 13. We multiply them together. So we not multiply the numerators and multiply the denominators. When there are no more common factors, we get 9 divided by 13. So that's the I think that, should I say the trick? Should I say that's a trick? Yeah, maybe. maybe let me put it that way. So now we're done with multiplication of fractions. Let's look at division. Let's look at division. Let's look at division. Division of fractions. Division of fractions. So let's say that we have again, we have maybe 4 over 5, and we are dividing it by, let's say this is 25, and then this is maybe 16, for example. So the first thing that we do is that we rewrite this again. We rewrite, we don't rewrite, we change. After writing the 4 over 5, we change this division into multiplication. And the moment we do that, the 25, the denominator goes up, and then the numerator goes down. It's called reciprocal. What we have done here is known as the reciprocal. We reciprocated reciprocal of the fraction of the previous fraction of the previous fraction of the previous fraction. Yes. Now what we do is that now we are going to apply the multiplication of fractions that we studied. We remember that we said when we pick, if we pick, let's say if we pick 16, it means we have to ignore 5. Ignore 5, go down the same line. Ignore 5, go down the same line. Ignore 5. We ignore that number, and then we look for common factors. Look for common factors. So is there any common factors between 4 and 16? Yes, it's 4. It's 4. It's 4. So it means that we're going to rewrite this again. 4 over 5 times 25 over 16. The common factor between 4 and 6 is 4. So it goes here 1, it goes here 4. What if we pick, let's say 25. If we pick 25, we ignore 1. We ignore this one here. And then we look for common factors. And there's a common factor, you can tell that there's a common factor. So it's going to be 1 over 5 times 25 over 4, right? This goes here 1. The common factor here is 5. So we have 1 over 1 times 5 over 4. And then there's no more common factor. So we multiply the numerators together and then multiply the denominators together. We get 5 over 4. And I hope this helps. And if you are asked to convert this, maybe your answer you're looking for is in mixed fractions, you know what we have to do. 4 goes into 5 what? 1. It goes into 5 1. That's the first method. Remainder 1. And then we divide it by 4 like that. All right. I hope this one helps. So we've looked at what? Addition, subtraction. We've also looked at multiplication. And we've also looked at what? Division. Now we're going to move on and look at how fractions relate to decimals. So we're going to look at fractions and decimals. We're going to look at fractions and decimals. Fractions and decimals. So let's imagine that we have this fraction here, which is 2 over 5, and we want to convert this into what? Into a decimal. What we do is that, like we always do, we'll say that let this 5 come outside. It'll be outside, and then in the long division we have 2 inside. All right, we have 2 inside, and we said that. Remember, we said that this 5 is known as a divisor. It's known as a divisor, which is the what? Which is the denominator, right? Is a denominator, and then the one inside here is known as the what? The numerator, or the the dividend, or the numerator, yeah. And then the one what we are going to get on top is going to be what we call the quotient. It's going to be our quotient, okay? It's going to be our quotient, or the whole number, or the whole number. So keep that in mind. If you don't get a whole number, then it's a decimal. A whole number or a decimal. A whole number and a decimal. And then whatever is left is a remainder. So now, do you think 5 can go into 2? Do you think 5 can go into 2? It's not possible for a big number to go into a small number. So because of that, we put 0 here. Because of that, we start with a 0 because it's not possible. If we multiply the 0 by 5, we get 0, and we subtract. Once we subtract, we get 2. The moment we subtract, we get 2. Now, we ask again, can 5 go into this 2? And it's not possible. So because of that, we put point here. Instead of putting a 0, there is already been introduced. So we put a point, and then we add 0 here. The moment we put a point, you add 0 to the 2. The moment you put a point, you add 0 to the 2 here. Now we can now say that, we can now ask the question, can 5 go into 20? Yes, yes, and it is 2, and it is 4. It is 4. So now 4 multiplied by this, 4 multiplied by the 5, we get 20. And we subtract again, and we get what? 0. We get 0. And once we get 0, we know that we've been able to achieve what we're looking for. 2 over 5 is now equal to what? 0.4. That's our answer. We've converted a fraction. We've been able to convert a fraction into what? A decimal. Now let's take maybe another one. Let's do the last one. Imagine that we have maybe 3 over 7. 3 over 7. We're going to have the 7 out. We're going to have the 7, sorry. We're going to have the 7 out, and then the inside is going to be 3. Can 7 go into 3? Can 7 go into this 3? No. So we put a 0, and then we multiply the 0 by the 7. Once we do that, we get 0, and we subtract. Once we subtract, we get 3. Now, can 7 go into 3 again? No. So there's already a 0, so there should be a point. And the moment we put a point, a 0 needs to be attached. Once a 0 is attached, we're going to multiply. We're going to ask the question again, can 7 now go into this 30? Yes, it's 4. It's 4. So that 4 times 7 is 28. 4 times this 7 is 28. And once you have 28, we subtract again, we get 2. Once we get 2, we ask the question again, can 7 go into 2? And it's not possible. Because it's not possible, we've already introduced a 0 at the top. We've already introduced a decimal point. So we are just going, because it's not possible, we just add 0 to the 2, and we get 20. Can 7 go into 20? Yes. It can go too many times. It's going to be 2 times. And 2 times this 7 is 14. And we get 6. Can 7 go into 6? No. There's already a 0 and there's already a point. So we add 0 to it. And 7 goes into 60. 7 will go into 60 8 times. And then we get 56. And what is going to happen is that this is going to continue. It's going to continue. So we call it recurring. It's going to continue. So it becomes what we call recurring. So we get 40. And then 7 goes into 5. And we get 35. And then to keep becoming 5, 5, 5, 5, 5, 5. So normally we'll say that 3 over 7 is equal to 0.4285, and then we put a dot on top, meaning that that 5 will keep recurring. It will keep recurring. It will keep recurring. So we've looked at fractions and decimals, and I want us to continue by looking at maybe if you have a decimal, how do we move a decimal? How do we change a decimal to a fraction? We've already done a fraction to a decimal. How do we change a decimal to a fraction? So imagine we have this decimal here. We have 0.01602 as a, let's say, a decimal. What do? We want to eliminate this 0. So what we do is that we rewrite this again, 0.01602. To eliminate the decimal point, to eliminate this decimal point, we move it to the right. So it's going to be 1 here. This is the first one. This is the second one. It's going to be the third one. This is the fourth one. And then finally, this is the fifth one. So once we do that, we're going to get 0. We've moved it. So 0.01602, and then the decimal point is here. So it's after the 2. We don't need to write it. But remember, we've done it 5 times. To do that, because we've done it 5 times, we divide it by 5 zeros. We write 1, and then we add 5 zeros. 1, 2, 3, 4, 5. And then we can be able to, we've successfully been able to convert the decimal into a fraction, because now we are going to ignore the first 2 zeros. We're going to have 1602 divided by 1, 2, 3, 4, 5. So this is the numerator. We know this is the numerator. And then we also know that this is our denominator, meaning that we've been able to convert this decimal into a fraction. Now let's continue. Let's continue by looking at since we've been able to convert a fraction to a decimal to a fraction. Let's look at fractions and percentages. And how they tie in nicely. Fractions and percentages. So let's quickly look at fractions and percentages, fractions and percentages, and then maybe percentages to fractions, okay, to percentage, and then the percentages to what, decimals, like that. So let's look quickly. Let's look quickly at, let's say we have a fraction, maybe two. We have this fraction 2/5, and we want to convert it into a percentage. What do? We are going to write the 2/5. Let me rewrite this well. Sorry, let me rewrite this well better. So let's say we have 2/5, and we are converting it into what? We are converting it into a percentage. So we are going to have 2/5, and we'll just multiply by 100%. Multiply by 100%, we're going to get 2/5. Multiply by 100%, and then we look for what, common factors. Don't forget, look for common factors, because the 100% is also over 1, right? We can write it over 1 like this as a fraction, and we know now we have multiplication of fractions. We're going to apply the rules of multiplication here. So we look for common factors. And we can see that's a common factor between this 5 and 100, which becomes what, 20. Well, 20 times 5 is 100. Now we have 2/1 times 20 with a percentage still there over 1, and then there's no more common factors, so we multiply the numerators together, and then we multiply the denominators also together, so we get 40% as a numerator divided by 1, and then we end up getting 40% as a change or converted fraction into a percentage. Now we're also going to look at how if you have a percentage, how are you going to change that percentage into a fraction? I'm going to change that percentage into a fraction. So let's imagine that we have 62%. Let's imagine that we have 62. Let's imagine that we have 62%, and we have to convert it into what? A fraction. So what we're going to do into a fraction, what we are going to do is that we know that percentage means, percentage means divided by 100. It means divided by 100. So it means that our 62% is the same as 62 divided by 100. And so far we've been able to do that because this is the numerator. We know this is the numerator and then the denominator. All right. So now we just have to simplify. If there's a common factor, between 62 and 100, yes, there's a common factor. 2 goes into 62, 31, and 2 goes here, 50. So it gives us 31 over 50 as the fraction. If we have maybe 58%, don't forget it's the same as 58 over 100. So percentage means divided by 100, and then we look for the common factors. We look for common factors to just simplify. Maybe it might not be in the exam. Whatever you have done so far is not a possible answer. So we know that 2 can go here maybe 29 times, and 2 can go here 50 times, and then there you have it. So we've looked at how to convert a fraction to a percentage, and how to also convert a percentage into a fraction. Now what if we are given a percentage and they want us to convert that percentage into fraction? So let's say, for example, the percentage to a decimal, or the decimal to a percentage, right? So remember, if we have let's say let's say we have maybe 53%, and want to change this to decimal, it's going to be what? First, to convert to what? A fraction. We're going to get 53 over 100. Once we have this, we let 100 come out, and we have 53 going there. We begin the decimal process. 100 cannot go into 53, so it's 0 here. 0 times the 100 is what? 0, and we have 53. We subtract it, and then 100 cannot go to 53, so we put a point. And when we do that, we add a 0 here. 100 can go into 530. We'll go inside 5 times, and we're going to get 500. We subtract, and we get 30. 100 cannot go into 30, so we add 0. We don't go to put a dot anymore because we have a decimal point on top. And 100 will go into 300 3 times. We're going to it 3 times, and 3 times the 100 will give you 300, and then we have our 53%. We now finally have our 53%. We have our 53% now being equal to our 53% is now equal to 0.53. It's now equal to 0.53. not equal to 3.53. Now let's also look at where we rather have the decimal. There's a decimal that we have, and we want to convert that decimal into a percentage. So let's say we have 0.43 and want to change this into a percentage. What do we do? First, we need to remove the decimal point, and to do that, we rewrite this again, and then we change it. We start moving it. Move this one to the right. This is the first one, and this is the second one. So it means we're going to divide this. It's going to be 0.43. We've moved the decimal point. We divide it by two zeros. So one, and then in the two zeros like this. And this is going to be the same thing. It's going to be the same thing as 43 divided by 100. And this is what we've been able to move from decimal into a fraction, and then from the fraction, we can be able to do our percentage. And to do that, we say we have to multiply by what? By 100%. So we multiply by 100%. That means we want to go into what? Percentage. This 100 cancels this 100, and the percentage is still there. We get 43, and then the percentage attached to it. Now we're going to continue. We're going to continue to move on to the next I think topic, and fractions, and all that we need to know about fractions. And I think that has to do with the decimal places. We're going to look at decimal places, and then we'll look at maybe significant figures. So decimal places is very important. Sometimes we can be asked to leave an answer in two decimal places, or a specific a specific decimal place. So let's say that we have 0.01602, and we are being asked to look for maybe the one decimal place, maybe one decimal place. Now, anything after the decimal point is a first decimal place. It doesn't matter whether that number is zero or not. So if this is the decimal point, this one here is the decimal point, and what is after the decimal point? Then what is next? This is what is next. So this becomes our first decimal place. Our first decimal place. Our first decimal place is zero. So if they say that, write this in as a first to one decimal place, since it's a zero, and since it's zero, it means that this whole thing is zero. This whole thing is zero. It's going to be equal to zero because the first decimal place means zero on its own. So it's zero. It's zero. You can tell that it's zero. It's zero. Because when you go to the number after it, this number is less than this one here. It's less than, and it's also not equal to 5. It's not equal to 5, so it's zero. But if this one was maybe 5, it was 5 or greater than 5, we're going to add 1. We're going to add 1 to the 0. We're going to add 1. We add 1 to the 0. We're going to add 1 to the 0, but it's not. It's not. So let's look at the same question. 0.016 602. So let's say we are looking for the two decimal places. They want us to leave the answer in two decimal places, and we said that what is a decimal? This is a decimal point, right? This is a decimal point, and any number after the decimal point is the what? Any number after the decimal point is known as the first decimal place. So it means that this is our first decimal place, and then we're going to continue. This next one there, this one here, is the second decimal place. But what is the number next? The number next to it, this number here, is greater than 5, and because of that, we're going to add 1. We're going to plus 1 to what? To the second decimal place, and when we do that, we're going to get 2, because our second decimal place is 1. So we add 1 to it, it's going to be 2. So we are going to have 0.02, and then we are in the 2 decimal places. I hope this helps. Now we're going to look at maybe significant figures. Let's quickly look at significant figures. We're going to look at significant figures. That can be a little confusing, but I think you'll be fine. You'll be fine. I know you're smart. It'll be great. So don't be scared about it at all. So now with significant figures, they're a little different. The difference is that when a number when a number begins with zero, it's insignificant. We don't consider the zeros. We don't consider them at all. We don't consider them at all. So let's say that we have this number, for example. Let's say we have 500. This number 500 is considered one significant figure. It's only one significant. The number there, the only number that is significant here is the whole 500. The whole 500 is the significant figure. It's not two numbers that are there. It's only one number, which is 500. So gives it what? That makes it a one significant number, a one significant number. But if we have 500.0, it becomes a different ball game altogether. It becomes a different ball game altogether, because the numbers, we have the numbers before the zero. We have numbers. There are some numbers, numbers before this zero. How many numbers are before the zero? They are 500. It's three numbers, and those three numbers, there are three numbers. There are three. It's called three numbers. Yes, three numbers. The numbers before this zero is that there are three numbers. What are the numbers? Is 5, 0, and 0, and that gives us what? Three numbers, three significant numbers. And why are we saying there are three? Because there's a decimal point here, so we don't count this 500 together. This is one number. This the second number, now the third number, because it's a decimal number. The 500.0 makes the whole thing. The 500.0 makes this whole thing decimal. So we don't consider this 500 altogether in its entirety. So that makes it what? A three significant number. Three significant. So this number here is three significant figures. It's three significant figures. It's three significant figures. I hope that clarifies a little bit of information for you. Now let's say that we have maybe a number. Let's say we have let me use the blue. Let's say we have 0.08675. Let's imagine we have 0.08675, and we are asked to look for one significant figure. One significant figure. Now remember, the number before the after the zero, the number after the zero, the number after the zero, the number after the decimal point. This is a decimal point. No, okay. And if it was decimal places, the number after the decimal point, which is zero, would have been important. But because we are dealing with significant, the word there is significant. The zero after the decimal point is insignificant, because there is nothing. Because there is nothing. And if there is nothing, this is not. We can say that this is not significant. It's not significant. And if it's not significant, which one is significant? This is the next one. The second decimal place is the first significant number. Why? Significant number. Why? Because this one is zero. The first one is zero. The first decimal point, decimal place, which is zero, is not important. So the second decimal place is rather our first significant figure. Now, the moment we are able to locate our first significant figure, this is our first sig fig. What is the number after? This number is greater than 5. And since it's greater than 5, we add 1 to it. So it's going to be 0, right here. It's going to be 0.09, because this 6 was more than 1. So we added it here. And then we go to what? 0.09. So we've been able to leave it in what? One sig fig. If it was what? If the question asked us to live in one decimal place would have been what? One decimal, we have 0.08675. One decimal place, we would count this as our first decimal place. And the number after this is what? Is greater than 5. So we add 1 here. So it's going to be 0.1. That'll be one decimal place. And then 0.09 is one significant figure. I hope this helps. I hope this clarifies a lot of doubts for you. So those are significant figures. Now, let's move on to, let's look at standard form. Let's quickly look at standard form, and then maybe do a question on BODMAS. So let's look at standard form. Let's look at standard form. standard form. And in standard form, let's say we are imagining that we have, let's say, we have maybe 42, and we want to write this in standard form. Now remember, 42 as a fraction, as a fraction is equal to 42 over 1. But 42 as a decimal is what? 42.0. The decimal point is behind it. Is behind it. And this is what? How many significant figures are there? There are only two sig figs. It's only one. Oh. It's only one, please, because there's a decimal point here. So the numbers before the decimal point are the significant numbers. There are two of them there. It's not 42, but 4 and 2 because of the decimal point. We don't see this 42 as a whole number on its own. So two sig figs. But anyway, let's move on. So our 42 is the same as 42.0. So how do we write this in standard form? We want to bring this. The goal is to move this decimal point so that it can fall between the first two numbers. And the first two numbers is this one here. So we're going to get 4.20. And remember, we did it only once. And once we did it only once, it's going to be times 10 to the power of 1. It's going to be times 10. It's going to be to the power of 1, like this, right? It will be 10 times to the power of 1, like that. It's going to be like this into standard form. Now let's say that we have let's say 914, and we also want to write this in standard form. Or let's say that we have a decimal number rather. Let's say we have a decimal number like maybe 0.914, and want to write this in standard form. We first of all need to move this so that it will fall between the first two numbers. It's going to fall between the first two numbers. And to do that, we're going to move this. It's going to be 0.914. And we're going to move it between the first two numbers. And this is the first two numbers. Sorry, let me rewrite this again. Sorry about the confusion. Let me write this again, please. So let's say we have 0.914. We want to move this to be here. And that's going to be what? 0.9 point, right? Let me do it again. Let me say it again. I think I was clumsy all over the place. So let's say that we move this one here. It's going to be 0, 9, then a dot, and then we have 14. But remember, 0 is not important, so it's going to be 9.14. But remember, we did it how many times? We did it once. And once we did it once, it's going to be 9.14 times 10 to the power negative 1 times 10 to the power 10 to the power negative 10 to the power negative 1. We've been able to convert this whole thing into what? Standard form. Now, let's quickly look at a problem. Maybe let's quickly look at a problem on BODMAS. Let's look at a BODMAS question to be able to bring our discussion on fractions and everything that we need to know, about fractions. So we're looking at PEMDAS. PEMDAS. We're also looking at BODMAS. Now we know what PEMDAS is, right? So let's imagine that we have PEMDAS. We are saying that the P is the parentheses, the exponent is maybe the exponent or power, and then we are saying that this is the multiplication, this is division, and this is addition, and this is subtraction. Basically, PEMDAS is telling us we should solve problems in this order. The parentheses first, whatever is in the parentheses need to be solved. And the next thing to do is a power operation. We need to solve anything that has a power next, and then we move to multiplication, and then we move to division and addition and subtraction in that order. What about BODMAS? It's the same thing. It depends on the country in which you are. In the US, what we know is PEMDAS. In Africa and Europe, it is called BODMAS, and I think it's almost the same thing. There's some little slight differences. So the bracket, the B is the bracket, which is the same as parentheses, and then there's this off, which sometimes is normally multiplication, and then like if you have a question that has off in it, you need to do that first before you come to the division, which is D, the division, and then the multiplication is the multiplication, and then you have addition, and then you have a subtraction. So I think at least here, the order is almost the same here. All right, the order is almost the same here, and then here too you have your multiplication, your division coming before another multiplication. So I think it's almost the same. So let's look at a problem. Let's look at a question on maybe BODMAS. So let's imagine that we have, let's say, 5 whole number 1 over 3, and then we are dividing it by, let's say, 4 over 7 minus, let's say, minus 1 over 2. Sorry, no, 1 over 2. Let's say minus 1 over, give me a second. Yeah, minus, let's say, 1 over 3. Let's look at minus 1 over 3. We look at 1 over 3, and then we do an off. Okay, or let me say multiplication. Let's put a multiplication in there. Let's put a multiplication in there. Multiplying half, and then we are adding it to maybe we're adding it to maybe 1 over 3, and then we're having a division, a division of, let's say, we have 9 here, and then we have 1 here, and then minus 1 over 7, like this. So we've created our own problem. So let's see how that is going to help us in solving this particular problem. So to use PEMDAS, we're going to attack the parentheses first. Whether it is BODMAS or PEMDAS, we have to attack we're going to attack the parentheses first. And in the parentheses, there's a subtraction and a multiplication. So if you look carefully, we need to always do the multiplication before an addition. So we're going to, in the parentheses, we're going to solve this one first. So we're going to write this one thing down, the same thing, write it down. We're going to have 4 over 7, and then here there are no common factors between them. So we multiply the numerators. 1 times 1 is 1 divided by what? 3 times 2, which is 6, because there are no common factors, plus 1 over 3 divided by 1 over 9 minus 1 over 7. We continue, and we continue with the parentheses. So 5 over 3 divided by, we multiply this and this, which gives us what? 24. And multiply this and this with minus 7. And then we multiply this, which gives us 42. 7 and 6 gives us 42. And then now we're having our plus 1 over 3 divided by 1 over 9 minus 1 over 7. The next thing is to do the division. There's one division here, and there's another division here. So it's up to us what we want to do. So we're going to get 5 1 over 3, 5 whole number 1 over 3, divided by this, and 24 minus 7 is 17 over 42. And then we're going to have plus 1 over 3. And we change the sign. We change it to multiplication, and then 9 goes up, 1 comes down, minus 1 over 7. And then we're going to get, we're going to also do the division that is here. Remember, we have to change this. We're going to be able to change this into improper fraction, so that we're going to get 15 plus 1, which is 16 over 3. We'll change the sign. We get 42 over 17 plus the 1 over 3 times the 9 over 1 minus 1 over 7. Now we can be able to work this and work this one out before we do any addition. And to do that, we will look for common factors. Is there any common factor between 3 and 42? What about 14 times 3? This is 2 carry 1. Yeah, so 3 will go here 1. It will go here 14. It will go there 14. So it's going to be 16 over 1 times 14 over 17 plus. There's also a common factor here. It goes here 1. It goes here 3. So we're going to get 1 over 1 times 3 over 1 minus 1 over 7. Now we're going to multiply the numerators and the denominators. So 16 times 14 is 4. This is 26 times 4 is 24. 4. Remember 2. 4 times 1 is 4. Plus 2 is 6. It goes here 6. This one 2 is 1. You get 4, 2, 1, 2. You get 224. The numerator is 224 over 17 plus. This one is going to give us 3 over 1 minus 1 over 7. What do we do first? We always have to do addition before subtraction. So this and this is going to multiply. Let me take a yellow color. This and this will multiply, and that is going to multiply. So we're going to get 224 plus 17 times 3, which is I think 51 divided by the 17. 17 times 1 is 17 minus 1 over 7. And I believe you can be able to finish this off. You can be able to deal with it. So congratulations for joining us. If you haven't yet subscribed to our channel, please do that so that we can grow this family together. Our goal is to make tutoring easy, and so that when you come here, you get all your tutoring needs, whether it's math, whether it's probability, whether it's statistics, whether it's physics, chemistry, math. Yeah, we're going to start gradually, and we are going to be able to finish and be able to provide the help that we need to help for everybody else in the world. All right. So I'll come to you another time with another topic. Take care and bye.